Good day, everyone. Again, this is Teacher Harold, your junior high school mathematics teacher. In this next video, I'll be discussing the second lesson under week number 3, and it is the area of a circular sector. And at the end of this lesson, learners are expected to compute for the area of a sector and answer related questions. To compute for the area of a circle, it is simply the product of the value of pi and the square of the radius r, or using the formula A for area equals pi r squared. In this material, we can also compute for the area of the portion of a circle bounded by the radii r, or the two radii that make the central angle theta. Such portion or part of a circle is called sector. The area of a circle of radius r is A equals pi r squared. A sector of this circle with central angle theta has an area that is the fraction theta over 2 pi of the area of the entire circle. See the figure below. So the area of this sector, the shaded part from the figure is, okay, but first let me show you the figure. Okay, so this is the circle. The shaded part is actually the sector. So again, so the area of this sector, the shaded part, is, okay, so we have two formulas for such area. One is capital A for area is equal to theta over 2 pi multiplied by the area of the entire circle. Or you can consider the second formula to compute for the same area of the sector, and that is equal to theta over 2 pi times pi r squared. Now simplifying this by cancelling the pi symbol, we will have 1/2 of r squared theta. The area of a sector. In a circle of radius r, the area denoted by capital A of a sector with a central angle of theta which is in radians, is A equals 1/2 the square of the radius multiplied by the measure of the central angle theta, where the central angle theta must be in terms of, again, radians. Now let us consider some examples. Find the area of the sector of a circle with central angle whose measure is 60 degrees if the radius of the circle is 3 meters. So for our solution, let us write the given information. So the length of radius is 3 meters while the measure of the central angle denoted by theta is 60 degrees. And let us consider an illustration of a circle with labels central angle whose measure is 60 degrees and the length of one radius is 3 centimeters. And the shaded portion is the sector of this circle, which is the one we're looking for. So now before we could use the formula to compute for the area, we must first convert the measure of the central angle from degree measure to radian measure. So considering the measure of the central angle theta, which is 60 degrees, we simply multiply this by pi over 1 180 in order for the given angular measure to be expressed to radian, and that will give us pi over 3 radians. And this is what we're going to use for the computation of the area of the sector. Thus, the area of the sector, given by the formula A equals 1/2 r squared theta, we have, okay, substituting the value of r and theta, that will give us 1/2 3 squared times theta, which is pi over 3. Okay. The common factor 3 is to be cancelled out, so that the simplest form of an answer would be 3 pi over 2 square meters, and this is the area of the sector, this one. Okay, that is your answer. Next, we go to number 2. The area of a circle is 36 pi centimeters squared. Find the area of a sector of this circle that subtends a central angle of 2 pi over 3 radians. So, solution. Again, we consider a drawing of a circle with the labeled measure of the central angle, which is given in terms of radians, so that is 2 pi over 3. And the area of the circle is given as 36 pi square centimeters. So what would be the formula? Yun. So again, the given information here from this problem is the measure of the central angle, which is 2 pi over 3, and the area of the entire circle, which is 36 pi square centimeters. So what would be the area of the sector? The area of the shaded portion of the circle. Okay, so actually we have a formula, and that is, okay, using the formula and substitute the given value, so that will give us 2 pi over 3, which is the measure of the central angle, times the area of the circle. Okay, so we have, okay, I think may kulang dito. Okay, 2 pi over 3, that is to be divided by 2 pi, and then multiplied by the area of the circle. Okay? Yan. Okay, so I was not able to include the formula that we used here to compute for the area of the sector. That is actually equivalent to the measure of the central angle in radians divided by 2 pi, then you multiply that by the area of the entire circle. Okay? And then from that formula we substitute the given value. So substitute the value of theta, that is the measure of the central angle, 2 pi over 3 over 2 pi, times the area of the circle, which is given as 36 pi square centimeters. And then we simplify this portion. That will give us at this point 1/3 of 36 pi square centimeters, or that will give you 12 pi square centimeters. And this is the area of the sector. And this is the answer. Next. Example number 3. A circular sector bounded by a 5 pi over 6 radian central angle has an area of 15 pi square meters. Find the length of the radius. Now for our solution, again, we draw the circle, labeling the unknown length of the radius as small letter r, and we also label the opening of the central angle, and that is the measure of 5 pi over 6 radian. And the area of the sector, which is 15 pi square meters. So what is the area of the sector? Okay. So what is the length of the radius? Okay. So for our solution, we just simply write down the given information. And those are what? The measure of the central angle, which is theta, equals 5 pi over 6. And the area of the sector, which is 15 pi square meters. And the one we're looking for, the length of the radius, denoted by small letter r. So using the formula, area is equal to 1 half pi, 1 half r squared theta. We directly substitute the value of these two parameters on this side of this equation. So, together with the area of the sector as well. Okay? So, in order to compute for the length of the radius, so the area of the sector is A, which is given as 15 pi. Then copy this one, 1 half r squared, and the value of theta, which is already given here, which is 5 pi over 6. So we substitute. And then we manipulate the equation, solving for r. Of course, pi will be cancelled because the two pi's are present on both sides. And then simplify the resulting equation, solving for r. Okay, so these are the steps. First, we have this equation. And then we cross multiply 15 by 12, that is 180. And what will remain on the right side is 5r squared. And then we simply divide both sides by 5. So 180 divided by 5 will become 36. And 5r squared divided by 5 will be r squared. And then use the symmetric property by interchanging the left and right side of this equation. So that will give you r squared is equal to 36. And then get the square root of both sides so that you will get 6, which is equal to r, or r is equal to 6. This is actually the one we're looking for. The length of the radius is actually 6 meters. So ito yung sagot. Next. Number 4. Find the measure of a central angle that covers a circular sector with an area of 27 pi over 2 square centimeters and whose radius is 6 centimeters. Now for our solution, again, we consider a drawing, labeling the length of the radius, which is 6 centimeters, and the measure of the central angle is unknown because that is what we're looking for, but the measure of the area of the sector is given as 27 over 2 pi square meters or square centimeters. Okay, we write the given information. Okay, the area of the sector, which is 27 pi over 2 square centimeters, the length of the radius, and the one we're looking for, the measure of the central angles, the central angle. Okay, so using the formula, A equals 1 half r squared theta, substituting the given values, that will give us 27 pi over 2 equals 1 half 6 squared theta. So transforming the equation, solving for theta. Okay. So kinopya lang natin and look what happened at the end. So basically, you multiply both sides by 2 in order to eliminate the denominator 2. And that will result to 27 pi equals 360. Or not 360, it's 36 theta. Okay? So divide both sides by how much? Okay. Now since we're solving for theta, so divide both sides by 36, if I'm not mistaken. So the 27 over 36 will give us 3 over 4, or that will be 3 pi over 4. Okay? And that is actually the answer. The measure of the central angle is actually 3 pi over 4. And this is your answer. Okay? So, kung walang tanong, that would be all. And see you next time.